Morning, ladies and gentlemen. My name is Munshi. I'm the executive chair of Pepperdata. It's my distinct pleasure to introduce two very well-regarded gentlemen, both of whom I consider my friends, who've had storied careers in their own right. Claus Moldt. Claus has been in engineering and CIO roles throughout his career. We joke about how we both started at Oracle at about the same time and worked our way through. For those of you who don't know, Claus actually worked on some of the DBA stuff that actually Oracle had at Oracle 6 and worked his way up. He has been CIO at Salesforce. Before that, he was at eBay, leading organizations implementing large-scale data systems across both enterprise organizations, i.e. Salesforce, and consumer organizations such as eBay. So Claus, welcome. Thank you for taking the time to participate in this discussion. Next, next is Sanjeev Mohan. Sanjeev also, believe it or not, started at Oracle. So all three of us are Oracle alumni. Sanjeev then left Oracle to join Gartner as an analyst. Was a Gartner analyst for a long time, covering all of the technologies that we're going to be talking about throughout this, throughout not only the session, but throughout the entire conference. Most recently, he has left and now runs his own consulting organization, which is really hard to remember because it's part of his first name and part of his last name. So in case anybody doesn't know, it's SanjMo. Look him up. He is an incredible human being. And very, very delighted to have both of you join us in this conversation. Thank you both.
Thank you.
Let me start, Sanjeev. The data stack, particularly as we start sort of a Hadoop circa 2010, 8, 9, 10, somewhere in that range, has evolved quite a bit. Would you mind walking us through the evolution of that stack to present day and where you think sort of the key investments are that people need to think about?
I'm really happy to be here and talk about how the space that I cover, which, so-called big data space has evolved. I believe Hadoop is the one that gets a credit for ushering us into this world where we could finally process massive scale of data on very cheap commodity hardware. And now we give a lot of criticism to Hadoop, but I think Hadoop was really the first time we could do this. It had a lot of limitations. At the time when Hadoop came out, networks were very expensive. So this whole notion of segregation of compute and store was not even in our purview at that time. So everything was sort of clubbed together. Using MapReduce on a distributed architecture, we could process the data, but it was almost always a batch processing engine. Initially, we were writing all kinds of scripts in Pig and all difficult languages till Spark came up, and Spark also went through its own iterations of RDDs, and then it settled on data frames, and things got easier. But one thing that we did not pay attention to in Hadoop, which is what led to this whole joke about data swamps, was that there was no metadata. It was very hard to discover what data existed, who had access to it. So the whole security, access, business semantic layer, all that was missing. When cloud came out, we finally had this true segregation where I could now scale my compute, I could scale my storage independent of each other. So I didn't need to always go buy a single computer and then keep buying more and more of those. So cloud has been massively transformational. I even see a lot of old-time databases have been rewritten to take advantage of putting data on object store. So with this rise of object stores, we now have the so-called modern data stack. With emphasis on doing ELT, so extracting data from sources, loading it, transforming the data. So a lot of companies get credit for being an essential part of ELT. We have the governance layer, the orchestration layer, the security layer, and finally, at the consumption, because now we have so much compute power, we can finally get our data science workloads to perform. Ironically, a lot of machine learning algorithms are not new. They're decades old, but we didn't have the resources. So today we can ephemerally, we can scale up 1,000 GPUs, train a machine learning model using a deep neural network algorithm, and then shut it down and stop paying for it. So this is where we've come in a very short span of time. I would say from 2006, when Hadoop came out and AWS was launched, till 2022, we now have really the power and we are applying some structure into how we are doing data and analytics.
I think that's spot on, Sanjeev. And, it also obviously poses a set of challenges because you have so much right at your hand, right? One of the things that I've been seeing is, since it's so easy to spin up resources, add resources, how do you still focus on making that cost effective, right? Because you can spend, hundreds of $1,000s in an instant if you don't do things right. So it's fascinating how easy accessible it has become, but also how you have to wrap, processes and procedures and governance structures and all of these things around what you're building, because the technology is evolving faster than ever.
If I'm running an organization, how do I make my bet? What bet do I make? Because am I in danger of making a bet and then a year from now, all of a sudden it's the wrong bet and I've got an entire infrastructure built on that? How do you think about that problem?
In my organization, we always spend a lot of time validating the technologies, right? And the competing technologies, really doing an extensive upfront understanding of what the technologies are capable of. And if it suits our use cases, more importantly, because you may still bet on a technology that may not be good for your use case. I've seen that happening several times. It may be the best technology that you know in the industry, but it may not suit your use case. And that means that the cost overhead of running something like that may be extreme. So the validation for your use case and tie that into what your priorities are for the organization is absolutely key. Then you obviously have to understand what's backing it. It's like, frankly, investing in any startup and making, from a VC standpoint, making sure you've done your due diligence, making sure that it's the right team that supports it, making sure that the technology will suit your use case, and then how it fits into what you're building. And if you do that, I think you're probably going to have a good outcome, because I've seen a lot of technologies, and most technologies we can make work. That doesn't mean that it's the right bet that you're making, right? So you really have to be very diligent and take the time to do the upfront diligence on the technology that you're implementing. Fortunately, I think a lot of it will shake out itself, because if you do detailed due diligence, you'll actually find the pros and cons very, very quickly. And that's where I feel that the best technology in general are winning.
I want to sort of build on that, Claus and Sanjeev. We're all ex-Oracle guys, right? We all know about, buying an Oracle database and then being locked in. So this whole idea of lock-in scares the living daylights out of people. Mm-hmm. And it's fair, right? Whether you're locked into a database or a cloud provider or anything else. So everybody wants to sort of hedge their bets. And the hedging the bet these days is the famous open source stack, right? Is that really a true hedging the bets? And how do I choose open source versus a proprietary solution? What are the kinds of thoughts around that? Because, if I look at open source Spark, and then there's Databricks, which is the closed source Spark, so to speak, right? And then I've got Kafka, and then I've got closed source Kafka, which is sort of Confluent, but they're sort of presented in a different way. As somebody who is making decisions about the enterprise and implementing this stuff, how do you guys both think about making those distinctions and choices? And is open source the right thing to bet on?
I think open source definition has really been shaken up a lot. Even some licensing changes have happened. At one point, Elasticsearch was open source, MongoDB completely, but then they came up with their own changes to how the licensing is done. With Confluent, it's even more confusing because there's open source and there's stuff that Confluent has developed, which is in a different license, and then there's proprietary changes. And in my opinion, there are only two fully open source projects that have survived the test of time, are still independent, and they are Linux as an operating system and Postgres as a database. Both are pretty much de facto standards today. I feel that there is a lot of emphasis on open source. As a technologist, if I were to build an end-to-end data and analytics stack on open source, I can do it 100% today. For the first time, I now have every single piece available to me to build my entire stack. For example, so indulge me because I love geeking it out. And I know we are all engineers.
Please, this is awesome.
Okay, great, thank you. So imagine this, I use Postgres as my operational database. Then I need to build a whole modern data stack, let's say, but open source. So I use Kafka Debezium to take the changes and persist it into an object store. But before I even do that, I can use Flink, I can use Spark SQL, I can use KSQL, and I can do my operation analytics. Once I'm going to store it into an object store, I can use MinIO, Red Hat Ceph, Apache Ozone. So now I have my data in an object store. Now the question comes, well, how do I do analytics on it? Well, guess what? I've got Presto, Trino, Druid, Pinot, ClickHouse. So I have a lot of options to do my analytics on it. Now I want to do BI piece, so I can now even use Apache Superset. By the way, in order to tie all of these things together, I can use Apache Airflow for orchestration. I can use something like Great Expectations for my data quality monitoring. So as you can see, there are pieces for all of them. So now the question comes, so then we solve the problem? Well, not really. If you're a startup and you're really worried about cost, you've got the best engineering minds in it, then you've got all the tools. If you're a business user, I would think twice, because A, I need the skills. Secondly, I need to maintain and integrate all of these. And then I need to know what is going on. How do I observe data from begin to end? And that means like I have to build a lot of new stuff. So there are pros and cons, but technologies exist.
And as an enterprise, I have to now integrate them together to make it all work and put that together. That's got to scare the living daylights out of a CIO.
So I think Sanjeev is spot on. A lot of the experimentation, a lot of building prototypes and proof of concepts, etc. You can use a lot of the open source technologies. I still think that you can use open source technologies in your enterprise environment as well, but there's a significant amount of consideration that you have to do, right? You have to understand how well maintained is the open source. Can you get response to critical infrastructure patches that needs to happen, security patches that needs to happen? Do they meet your SLAs, for instance? You have to read the fine print, as Sanjeev also pointed out. Is it truly something that is open source and free to use, or is a license attached with it when you go commercial, which there often is? Do you have the internal know-how and domain expertise in order to maintain and upkeep, upgrade on a regular basis all the open source components? And do you scan all the open source components from a security standpoint, et cetera, to meet all the regulatory requirements that there may be as well, exports, restrictions, et cetera, et cetera. So you have to be really making sure that you catalog every single piece that you deem as open source as part of your solution set that you're bringing out. And then you have to make sure that you classify it in terms of criticality. What are the critical components? What are the non-critical components that you have in here? And what will you allow? What won't you allow? So yeah, there is a significant amount of evaluations, again, that you have to do from an open source standpoint, making sure that most of the things I think that we have used in my career is probably things where we had pretty significant internal domain knowledge of the open source components that we were using, so we could support it effectively. Otherwise, you go commercial, right? Because you want to make sure you have the 24/7, 365 support and people to jump on it and understand it. And that's a consideration that you're making. There's a significant overhead that is tied to using open source when you run in an enterprise-grade environment.
I know several extremely large companies that are using open source as their framework. And what's interesting is every single one of them has committers to the open source projects that they actually use inside their enterprise. Because what that allows them to do is allows them to, number one, get access to the right people very quickly. And number two, allows some measure of control about what's going on.
Correct.
Yeah,
that's absolutely correct.
If you look at Apple, for instance, they use Cassandra at scale. They're, I think, 150,000 nodes or more of Cassandra. They don't use a commercial version because they're Apple. They probably have more IT people who can commit to and fix Cassandra problem than a commercial vendor.
Yeah.
And to your point, Klaus, I remember I used to get a lot of client inquiries on Elastic. Elastic was hugely popular. It was a game changer when it came out, except the open source had no security, zero. If you wanted security, you had to buy the commercial feature pack to get security. So what options do enterprises have? They were literally, in order to save money, they got open source Elastic, but then they went to GitHub trying to see who had built an open source security layer to protect their Elastic deployment.
Exactly. I mean, it's very easy to fall into the trap, right? To really make sure that, you could start out one way and you know that you're going to end up another way. So as part of the evaluation, I think it's absolutely key to understand the monetary aspects of how you're going to use the open source and how critical it is in your solution set as well.
So changing topics just a little bit, guys. Thank you, by the way. Great answers. We look at sort of open source as one way of being able to essentially create new stuff in the environment. So basically, a bunch of people out there look at problems that are occurring. They get together to go create something that solves that problem, and we keep adding to the alphabet soup over time. We will do that. As you see that, there are clearly some problems today that aren't being solved by the current open source community or by actually commercial products. Sanjeev, as you talk to lots of people and lots of companies, what technologies are you seeing coming forward that we should have on our radar so that we can be prepared to be able to understand them and go through the process that Claus described about being able to figure out how and when we want to be able to internalize them? Can you walk us through some of these interesting things?
Yeah. So Ash, thank you for asking that. It is mind-boggling that 40 years since, we've been dealing with some of these, modern, so-called, relatively modern technologies, post mainframe era. Since client servers came out in 1980s, we still haven't solved data quality. Why are we still struggling about data quality? We're trying to do predictive machine learning and predict how our company will behave, and we cannot even trust our data. So one thing that really we dropped the ball on was this whole metadata management layer. And I'm happy to say that we're doing a much, much better job on it, except as everything, we have too much of good thing. So we have 30, 40, in fact, I track about 70 different data catalog companies. So you can see that is an area of immense focus. If I can get the metadata of my data ecosystem correct, then a lot of things hinge upon it. Not just data quality, data observability, security, privacy, compliance, migration to the cloud. How do I know what I should migrate and what I should not based on usage patterns? How do I know that certain workloads may run better on premises? So cataloging not just the data, but the business rules, constraints, creating maybe a knowledge graph of these, that is a piece, the business focused piece that is something that's work in progress.
This is where you see a significant amount of investments going in to piece these things together, right? And people have created their own set of standardizations for the standard of APIs, how do you do rate limiting, how do you do all of these things. But the observability is not only to the data, it's what you keep in the backend database, right? It's to everything that goes on within your environment, because you have to drive what you're doing with data. And then more importantly, tie that data into something that you can actually execute on. What do you do with the data? Because the automation aspects of having the accessibility to all this data that's being generated is absolutely key to automation techniques and things that you build. And that's ultimately how you will be able to scale large-scale organizations, right?
Very good.
You really need to understand what data you need and what do you do with the data. And frankly, one of the things that I think is going to happen more and more as well, Sanjeev, with the AI and machine learning technologies, et cetera, that's coming out, once you have the data sets, then you can create all the analytics that goes around the data sets that you have, whether that's operational data sets or business data sets or data observability data sets, et cetera. And you can automate based on that. That's where you become smarter. That's where you can do more things with less people and make things much more cost effective.
So let me see if I sort of understand what you guys just said, right? Sanjeev, I think you started off with basically saying that I've got data. I don't know where my data is. I don't know what happens to the data, who's generating what types of data. Becoming aware of that across the organization is an incredibly important thing, and being able to tie structure around that data and understand what that data is, right? And then I think Claus and both of you were saying that once I have all this metadata, well, that's also data of a different type. What do I do with that data, and how do I use that data in order to actually create better operations is the other interesting problem to solve. So the data itself generates effectively metadata, which if I manage that metadata correctly, allows me to then manage the data underneath in a nice way and automate all the processes and everything that's taking place. Is that a fair summary, guys?
Yeah,
yes.
It's a great summary. It's a closed loop. Yeah.
Yeah, and it's a closed loop to be able to go do that. You know, what struck me, Sanjeev, is your comment about let's understand the data. So I did for Gartner, I did a roundtable a couple of years ago with CIOs of companies from the oil and gas space, right? Mm-hmm. So you can think about the Chevrons and all those guys. And what was interesting was I said, you know, we focus on data, right? I'm a data guy, right? Let's talk about data. And, you know, the very first comment that I got back is, we don't actually know what data we have. Right? And then the second comment I got back was, and we don't know where it is. Right? I think it's a very real problem, right? I mean, we scoff at it in a sense because we kind of assume because we're dealing with tech companies all the time. But there are many companies that have data hidden all over the place that just, they don't know where it is. They don't know what it is. It might be buried in all these different systems. As an organization, how do I discover this stuff?
Yeah.
Go ahead.
There's definitely data discovery tools, right, that you can run within your infrastructure and environment. And there's also network tools, right, that you can get to. The challenge that you may find interesting enough is that if people have done things right, you know, data is encrypted at rest and data is encrypted as it flows through the systems. So it may not be as easy as it sounds just to find where the data is and what it's actually doing, unless you dig under the actual code of the systems to truly figure out what is where and when. And that can become a pretty significant amount of detective work to go through if you have a history, right? If you've gone from mainframe, et cetera, to where you are today. It's a lot easier when you're a startup and figure out things and smaller companies. But it's a detective work to classify and get all the data to understand. There's crawlers and other things that you can use to it, but it's never an easy task to undertake. I can guarantee you that.
I think that the biggest problem that we are facing in this space is lack of common interoperable standards. Everybody has data discovery today. If you are a big Kafka, like we were talking about Kafka, you're a schema registry. If you're an ETL vendor like Informatica, they do a lot more, but you have a data catalog. If you're a BI tool, you have a catalog there. Security and governance products, they all have catalogs. So what's happening today is that these companies are saying that I've got 4 pure play data catalogs, and I've got another half a dozen that just come embedded in my products. But I don't have a way to share that data into a master catalog, and that's where the problem is. And that's why, you know, we need to think of this holistically and centralize and have a catalog of catalogs. If we want to do things like data mesh and all kind of decentralized architectures, we need that single pane of glass, a single view of our metadata.
Yeah, very, very sophisticated CMDBs, configuration management. That is really what you have to do, and that's what I've seen that big companies are actually doing, putting together.
So you know what's interesting is both of you said the mainframe word, which I think some of our audience may never have even heard of. So we're dating ourselves when we think about the mainframe, but certainly, you know, the audience certainly knows about on-premise and cloud, right? Sanjeev, you started off by basically saying that, look, a lot of the limitations that we had in being able to build stuff on-premise goes away as a result of the cloud. And so the cloud is a tremendous tool to be able to, you know, sort of take the next step and be able to do things in a much larger fashion. If I could get both of you to talk a little bit about what do you think the big challenges are of basically migrating to the cloud and then staying on the cloud, or should I be hybrid? When does all that stuff happen, and how should I think about it?
So you know, a lot of things goes into in terms of where you are from a maturity standpoint in your company. That's one thing, and I'll just give you a couple of examples. If you already bought and own data centers, for instance, the cost of running a data center could be relatively cheap compared to running in the cloud. And that's where you'll see that some will actually still run their own data centers because it's all paid off. There's no really significant overhead in terms of cost. Of course, there's power that you have to pay for, but that's smaller than using units that you may buy from public cloud providers, for instance. The other thing that you also will find is that when you migrate from on-prem to cloud, unless you really have a good handle on cost associated with it, many times it can be more costly to migrate to the cloud if you really don't keep close tab on what you do. And most will set up just a small team that manages cost that's associated with it, so you really can track which applications are using what and is it really cost effective. When you do it right, then I do believe that the cloud becomes more cost effective if you're running in, for instance, co-locations and don't own your data centers, et cetera, and maybe even migrating from private suites in the data centers. Because the technologies where you just can spin up resources and shut them down when they're no longer required becomes very, very cost effective if your application can support it, right? We have applications in my lifetime that couldn't support it, where it has to be always on because the response time that's required. So you have to have a minimum set of resources that's available to you that will cost you as well. But still, it will be cheaper than running things yourself and maintaining things yourself. So I just think that you have to be smart about how you validate the cost and the benefits of it. But I would, if I can, any day go to the cloud and come such a long way from a security, operational standpoint, innovation standpoint, that most companies just can't out-innovate clouds in any way, shape, or form or make it even more cost-effective. That's just the reality at this point in time.
Yeah.
Sanjeev, your thoughts?
Yeah, so the last thing that I would like to add, because Claus covered it all, those were my biggest challenges with cost, security, and so on. The last thing, and the only thing I'll mention, is we have a very severe lack of talent or skill shortage. And to your both of what you're saying is that cloud makes things a lot easier, but then AWS has 200, 300 services. Somebody has to keep up with what is going on in just a single cloud provider, because every single day they have new stuff coming out. So how do I optimize it? What do I do to utilize this new hardware virtualization layer and an instance type that does push down to the hardware? All of that requires literally a full-time job to just keep up with the cloud providers.
I really appreciate your time. Any last thoughts and closing remarks for our audience?
Well, thank you for having us. And again, fantastic topics. We can talk about this for days.
Sanjeev, last closing thoughts on this?
It's such a pleasure talking to both of you. And like Claus said, we could talk forever. Thank you.
So thank you again. It was our pleasure, and have a wonderful rest of the conference.